So your chats are going to be recorded, just so you know, in case if you do not like it. Just be careful what you put in the chat. That's going to get into the recording. And we have our previous recordings, the one that the speakers gave us permission is there, and the future one will also be there. Today's one will be there by the weekend, because we are all volunteers, so we need time. We have other tasks, so check on Monday. These are some of the future sessions. So this is a 6-part series on Fabric. Today is the 4th one. There's a 5th and 6th one is coming up next month on the 14th and 28th. And then we have 2 more speakers lined up. Daniel is from Microsoft. The title is not here. I'll publish it as soon as I get info. And these are some future events. So most of these are a one-day event. We call SQL Saturday or Data Saturday, but some of our paid event. As you can see, there is a past summit in November. There's a future data driven summit, which is a one-day conference free of cost, all online. And this year PASS is doing something called like city tour. There's one in New York, one in Dallas. Those will be paid. Other than that, most of these are one-day free event in person. Most of these are in person. So check out the websites at the top, sqlsaturday.com and datasaturday.com. With that, I thank you, Andrew and Joey, for coming up, giving up your time and expertise. So this is a part 4 talking about GraphQL and application development. So I'm not going to talk about them. I'll let them talk. So I'll keep quiet. I'll go on mute. And you cannot unmute yourself if you're attending. So, but you can put your questions in the chat. Joey and Andrew is going to check the chat and will answer your questions in time. Thank you. All yours.
Okay, great. Hopefully our title slide is now showing, not that it's all that different from yours. Okay, and you can see the pedigree of this presentation. We did this for Microsoft Reactor, gosh, back in, I think it was November. Is that right, Joey?
That sounds about right.
Yeah. So these features have had some time to marinate. Still in preview, a lot of them, but we see them as very important to cover. I'll introduce myself and then let Joey do likewise. I'm Andrew Brust. Like Joey, I'm a data platform MVP. I have been working with Microsoft technology for way too long. I've been working with SQL Server since the first version of that product for Windows in the early 90s. Been working with Microsoft BI since the late 90s, big data technology since their inception, and I've been working with Fabric since its early preview days. As a day job, if you will, I'm both an industry analyst and journalist, also covering data and analytics, but with those hats on well beyond just Microsoft. So I cover the whole industry. My firm Blue Badge Insights does that on the analyst side. I also head up that category for a research company called GigaOM, and I write for a developer-oriented publication online called The New Stack. Again, covering database, analytics, BI, and of course these days lots and lots of AI. I'll let Joey share his bona fides with you now.
Thanks, Andrew. I'm also a data platform MVP, and I have been for a long time now, like 11 years, I think. I'm also a principal cloud architect at now 3 cloud solutions. I do a lot of consulting work around cloud and data. And I'm also a journalist. I write for Redmond Magazine. I just published a column yesterday on some new features in Azure storage and how I like to benchmark cloud storage. I've done a lot forever with databases, infrastructure, clouds, and a little bit of everything, and now a little bit more with AI. So looking forward to doing this talk. It's a fun one, and I like co-presenting with Andrew.
Cool. And although this is only our second ever opportunity to present together. So this is part of a whole series on using SQL in Microsoft Fabric. And actually, we like this particular episode because it covers more than just SQL. We'll get to that in a moment. This builds a little bit on stuff that was shown in the first 3 episodes, and I believe those are available for you as recordings, if not through this group, then through the original presentations last year. And we have 2 more coming up. and we don't have the dates on the slide, but I've now memorized that that's going to be May 14th and May 28th for the application lifecycle management and the developer-centric query and performance monitoring episodes, respectively. This content stands pretty well on its own. Where there are a couple of dependencies on other content, we'll just mention that so you don't go, hey, where did that come from? It won't seem like such an aberration. Anyway, what this episode does put together is not just using SQL and Fabric, but building GraphQL APIs suitable for calling from applications around those databases. And in fact, we're also bringing in some techniques to do vector search, which is a feature that's been in Azure SQL for a while and will be in SQL Server 2025. So that's the scenario for the demos that we're going to be showing. These demos are interesting because they're actually pre-recorded, and we are not the ones who recorded them. But we've studied them very carefully so that we can narrate them. And in fact, for this presentation, we're doing a little bit of a mashup. So the final demo that Joey will do will be live and interactive and not out of the can. But just so you can see the layers build on top of each other, especially what was built in the previous episode. We'll be sticking with those particular demos now. And we're going to kick things off by going into the first one. I'm not starting the video just yet. Let me just set up for you what's going to happen. This is a very long stored procedure with something like 4 different common table expressions. The gist of it is this, right? It's called find sessions. We're going to pass in an input text parameter, and that's going to be a search string of sorts. And we're going to actually thunk all the way down to the Azure OpenAI API to get a vector embedding for that. And then we're going to take that vector embedding and we're going to do a vector similarity search between that embedding and the sessions and speakers that are already in our database. Those are going to get mashed together. Then we're going to bring it back as a top 10 sessions that match the search expression. So I'm going to go ahead now and kind of start things up. And our minimum similarity that we want is 30%. And as you'll see, most of what comes back is pretty close to 80% similarity. That get underscore embedding is a stored procedure that was built in the previous module. And then we do the vector distance using the cosine type specifically. That's a feature in Azure SQL and Fabric SQL where we can get the vector distance between 2 embeddings. And again, we want to bring back only those where the similarity is at least 30%. And then we're going to grab the top 10. And as you'll see, as we scroll down a little further, we're going to bring back about 7 columns. And the very last column will have the so-called vector distance. And you'll be able to see again that most of those are around 80%. So we're bringing back ID, title, abstract, external ID, start time, end time, recording URL, and the speakers for the session. In effect, these are courses out of a catalog. And 1 minus the distance is going to be the similarity. And again, we want to make sure that's over 0.3, 0.3. That's the script. Let's run the script in order to compile the stored procedure. And then let's call the stored procedure. And we're going to call it, I say we as if we did this, but we're going to call this 3 different times. So the first time that we call this, we're going to give it a simple 1-word search string, which is technology, and we'll run this thing and we'll get back the top 10 sessions. That's pretty fast if you think about the fact that we actually generated an embedding for the word technology on the fly, and then we did the vector search. Notice in the far right-hand column, everything is 77% similarity and up. Now we'll put in community and youth and get back a different 10 sessions. And again, the same format. the same contents. Given that title and abstract are rather truncated here, you have to take it a little bit as an article of faith that that these are similar, but go ahead and have that faith. It's well placed. And then we're going to do this once more. And this time we're going to put in, if I recall correctly, we're going to put in the word ecology here, and we'll get back 10 more. I'll come back towards the end of the session, and you're going to see us build a little bit of a wrapper function on top of this stored procedure to make it directly callable by GraphQL. And it's from there that you could then go ahead and build out, for example, a web application on it. And that should bring us to the end of this demo. And with that, I can, hold on a second. We can move on to the next slide, and I can toss it over to Joey.
Thanks, Andrew. Let's talk about GraphQL. So GraphQL is a query language for APIs and a runtime for executing those queries with your existing data. If anybody's ever worked with a data API builder that Microsoft has built, hey, you're not sharing slides, by the way.
I'm not. What happened?
Yeah.
I'll go right back. Oh, I see. We good?
No.
No,
We
not
will
yet.
be in a moment. In a moment. Here we go.
Okay, go up one slide, or yeah, you can go back up one slide. Okay, cool. Yeah, just stay there. There's nothing on the slide before other than about. So yeah, GraphQL is a query language for APIs. Like I mentioned, if you've used the Data API Builder from Microsoft, which is what this Fabric solution is built on top of, that's an open source piece of software that Microsoft has built to allow you to build REST APIs and GraphQL APIs on top of a variety of databases. It supports using GraphQL. And GraphQL was developed by Facebook or Meta or whatever they call themselves before the DOJ splits them apart. It allows clients to request exactly the data they need, nothing more, nothing less. It gives precision here where it try to help reduce overfetching and underfetching of data. If you've ever seen sometimes REST calls get translated into really bad SQL, this is something that can be problematic. So GraphQL can help enable faster development, and front-end developers can shape responses to match UI needs without a lot of back-end changes. It also supports real-time updates with subscriptions and strong type checking. And unlike REST, where multiple endpoints may be required, GraphQL is going to condense data retrieval into a single endpoint. So it's a modern, efficient solution. And I feel like I've done enough marketing there. But we'll walk through some of the use cases you can have. Andrew, I'll have you flip the slide in a second, but stay here. Like I said, it doesn't rely on multiple URLs or endpoints, and some public GraphQL endpoints you can mess around with. There's a countries API called countries.trevorblades.com that's great for building dashboards, language selectors, or geography apps. You can also query GitHub with GraphQL. So if you hit api.github.com/GraphQL, you can hit that and start building some dashboards. GitHub's a really good example because it's one of those tools you probably know already, so you know some of the data. So if you want to learn the language, that's a good way to get started. There's also a Pokemon API, so beta.pokeapi.co/GraphQL. That will let you connect, as well as Fabric. So largely we're going to be talking about today. There's a built-in solution into Fabric that will let you just have a GraphQL API on a Fabric SQL database, and that's kind of what we're going to be talking about. If you can hit the next slide, Andrew. So you can access a large variety of databases with GraphQL. We're largely focused on, Fabric, a SQL database on Fabric today, but it works against Postgres, it works against MySQL. With the Data API Builder, it can work against on-prem SQL Server, it can work against Azure SQL Database, it can work against Cosmos. I have a whole app where I pull in all of the available Azure virtual machine sizes, and I hit it with GraphQL, mainly because it's a good demo, but once you get used to the language, it's really friendly and kind of easy to use. So lots of other databases make it easy integration. And really, it's typically as simple as defining the database objects you want to hit in your API, and then you can start to write GraphQL against them. You can host these anywhere. So today we're going to be hosting on my local machine. Hopefully my demo still works. It does. But Andrew's also got the same app. But if I wanted to, I could deploy that app that's going to hit Fabric Database to Azure Web Apps, Azure Static Apps, the app service. The app I'm talking about that I built myself for VMs is running on the app service as a container. So lots of ways you can host these apps. They're pretty straightforward web applications, and you can hit the next slide, Andrew. So when a client sends a request to a GraphQL API, that API is going to define exactly what data it needs using a structured query. That request gets sent to the GraphQL endpoint. Oh, the slide must build.
Yeah, this one's actually mine, but we can share it if you'd like.
Okay. Oh yeah, you're on 8. Never mind. Feel free to go ahead.
Okay. Well, it just proves that we both know all of this and we haven't siloed our knowledge. Anyhow, so yeah, this build slide really just tries to show you the kind of logic flow in terms of how an application works with a GraphQL API, and for that matter, how the API kind of encapsulates your data sources. So some of the stuff we're going to talk about today is in the generic case if you were implementing GraphQL on your own. In fact, with Fabric, a lot of the things we're talking about as kind of discrete efforts actually happen automatically. So one of those things is that you'd have to go and find yourself a GraphQL server. There are several open source ones, and you'd find one that would work with your language. Again, in the case of Fabric, though, this is all built in. But that GraphQL server is what will erect a GraphQL API, which is, it's comparable, I guess, to a REST API, except everything's going to be JSON based in terms of what you submit and what you get back. And it really is a nice encapsulation layer that is specific to working with data, and more specifically to performing the basic 4 operations with data: create, read, update, and delete. One of the nice things about GraphQL, as opposed to just writing your own very thin API over a single database, is that GraphQL can in fact talk to multiple data sources. So while the API might make it look like you're talking to a single data source and executing CRUD operations against that single source, in fact, the API can abstract away the complexity of dealing with many databases and data sources, including relational and NoSQL, even flat files and storage, whether that be kind of vanilla storage or a real data lake or lakehouse. And for that matter, though the slide doesn't show it, you could also be doing things like calling out to APIs and getting back their data. So that's a bunch of complexity that the developer over here on the left doesn't have to worry about. The developer is just going to put together a special JSON formatted request. There are 2 types. One's called a query and one is called a mutation. We'll drill down on that in a bit. That gets pushed to the API. The server then queries your various data sources, does all the magic it needs to, and it sends back another JSON document. And that will have, just as you can imagine if you were in SQL Server Management Studio, where you execute a T-SQL query and you get back a result set in a grid as well as several messages. That happens here too. You get a single JSON document that gives you back a combination of your data and the messages. Those could be error messages or just simply status messages. So that is the nice interaction on the left and possibly mucky complex stuff on the right. So as I said, forgive me for pausing there for a second. So let's drill down on some of the vocabulary so that I can get you into that distinction between a query and a mutation. So first of all, your GraphQL APIs are going to have schemas, and those schemas are going to have types. The types in turn will have fields, and really I'm sort of erecting a little bit of an equivalency vocabulary because a type is an awful lot like a table, and a field is an awful lot like a column in the table. Another way to think about things is that if you imagine having a database where you have a bunch of views for bringing data back and a bunch of stored procedures for modifying the data, you can think of your GraphQL API as being akin to that. But again, the schema is going to show you the shape of your data and the relationship between the types. And then we finally, this is really where I wanted to get, we have the queries and we have the mutations. So queries are, if we think about CRUD, C-R-U-D, create, read, update, and delete, or retrieve if you'd rather for the R, the queries take care of the R part, and the mutations take care of the C, U, and D, to create, the update, and the delete. As you'll see in a second, we'll get into some code samples, if you even want to call it code. It's very high level and declarative, but essentially, they look very much the same. It's pretty easy to kind of imagine the equivalent SQL that a given query or mutation represents, and in fact, we'll show you the equivalent. And there is also, in the world of GraphQL, although beyond the scope of our presentation, and I'm pretty sure beyond the scope of what you can do in Fabric itself, there is such a thing, or there are such things as subscriptions. And a GraphQL API subscription is basically set up to push notifications out to the application when underlying data changes. So it's a bit like a change feed or change data capture mechanism in a database platform. But again, we're really limiting our investigation here to queries and mutations. And Joey, this one's you.
Yeah, thank you, Andrew. You may ask, why do you want to pick up another language? And it's always a good question, because sometimes, dealing with SQL is much easier, and SQL is the language that will never, ever die. I am thoroughly convinced no matter what new form factor comes out, we'll write SQL for it. In fact, like when Hadoop and all those other big data platforms became a thing, the second thing that happened after all those platforms got built was people built SQL interfaces to them. But let's talk about GraphQL and SQL. They're both languages that are used to query data, but they serve different uses in modern development. Like Andrew mentioned, SQL is used to interact directly with databases. It allows users to perform those CRUD operations, and it's tightly coupled to the database schema. GraphQL, on the other hand, is more of an API query language, and it sits between the client or one or more data sources. And those could include SQL databases. And in the scenario we're going to be describing today, that's what they're going to be exclusively, is tables, views, and stored procedures. In the demo I built out, we're just going to be hitting a table, but you could also hit views and stored procedures. But it could also include NoSQL or other third-party APIs. GraphQL isn't a database language in and of itself, but it's a way to define and access structured data through that single endpoint. Clients are going to specify exactly what fields they want. The response is going to mirror that structure. And it's particularly useful for front-end development, where flexibility and control over return data are essential. So the purpose here, GraphQL is a language for APIs more than SQL is. There's a little bit more control in terms of what the client returns, whereas in SQL, the server controls what's returned. There's a little bit more flexibility, especially when dealing with deeply nested data. And SQL relies on the database schema for typing data, and GraphQL is going to use a strongly typed schema at the API level. So those are the main differences. And these things can work together. So GraphQL often calls SQL queries in the form of views or procedures, like I mentioned, but they do operate at different layers in the stack. So think of SQL as the tool to access your raw data, and GraphQL as the elegant interface that serves it to clients. You can hit the next slide, Andrew. All right, let's start talking about the basic structure of a GraphQL query. A basic GraphQL query is going to resemble the shape of the response you want. It starts with the query keyword, as you can see on this slide. This can be omitted for some SQL queries. There's a selection of fields here that are going to follow. And in this example, we see countries, but it could also be user ID and with name. And GraphQL queries can also accept arguments like ID 123, and it can have nested fields. So let's dive into this query specifically. So let's talk about this. So we have select star from country, which is our most basic SQL query that we should never, you can go back, sorry, that you should never write in your application, right? We always say never write select star in your app, because if your columns in your table change, it'll break the application. SQL is going to return all of those columns unless you narrow it down with naming the columns or a where clause. And really, this is nice, what we want for direct database access. But if we're doing that same query, we're querying the countries table, disregard the differing spelling of countries there. We didn't make this example. So now we're defining exactly what fields we want returned instead of returning all the fields like we would in a select star. So no extra data is sent, which is going to help us resolve that. And GraphQL is going to give us that flexible interface here. We can also include things like a where clause. We can build that into the app.
Right. That's gonna be in the next demo. I'll also just point out, as I feign controversy here, though, that's the fact that the table name and the type name are not the same. That's not necessarily an error. Actually, that's a feature, not a bug, right?
Yeah.
It doesn't matter what the table's called. Call your types whatever you like to. Use the plural rather than the singular if you wish. Right, that's the point here.
So that's a very good point. So like if your alias or that countries was a view, yeah, that can all be defined in your API layer.
Very good. Shall we move on?
Yeah, go ahead.
Okay, cool. And sorry for the goof up on the slide there. So again, a query is what's used to retrieve. We are going to get into mutations, but what you saw here, and then actually what Joey alluded to, is that was just a straight select star without any kind of criteria at all. And of course, in the world of SQL, you have where clauses, and in the world of GraphQL, you can set up arguments, and you can also set up filter expressions. So if we keep going here, we've got another query. We're still not on mutations, but we have another query here. And in this case, we have a nice specimen of the syntax I like to make fun of, which is contained within these parentheses after the word languages. So now we're not getting countries, we're getting languages. We are going to get the code field, the name field, whether or not it's native and whether or not it's right to left. At least I assume that's what RTL is there for. So languages like Arabic and Hebrew can be accounted for. And basically what we're doing is we're creating an argument on the code field. And what this means, don't be scared by all the curly braces. It just means that we're saying where code equals EN, as in English. Of course, if this offends you or gets you kind of overwhelmed, well, just look at the SQL up here in red, right? Because that's all we're doing. Select code name native RTL from language where code is equal to EN. But again, when you're doing this in SQL, you're really speaking to the physical and actual structure of a physical table. When you're doing this in a GraphQL query, you're really referring to a more abstract type that may be encapsulating various things, or maybe it's encapsulating exactly the same thing, but maybe the column names are different than the field names, for example. So you can have arguments without a filter, by the way, but the filters are nice because they let you string together multiple conditions and use logical ands and ors. And that, I think, is a good toss back over to Joey to talk about those things.
Yeah, so fields, let's talk about fields and arguments. And we had a question in the chat about, where GraphQL ties into Fabric. And specifically, it ties in that there's an easy to use GraphQL endpoint for your Fabric SQL database. And we'll demo that as we move a little bit forward. But let's just talk about some of the terms in GraphQL, specifically fields and arguments, which are really the essential components of a query. So fields are going to mirror what data the client wants. Like the example Andrew just showed with countries where language is English, we can fine tune that. So we can use arguments like filters or parameters. Those filters and parameters can be thought of as being analogous to where clauses. Like Andrew mentioned, they work together. Those arguments are gonna be fields are going to be like a column, arguments are going to be like a where clause, but you can also use arguments to do things like sorting and pagination. They're not limited to filters, so you can use them for sorting using an argument like order by, or pagination like arguments like first and after, or even search terms. So you could say, date descending, first 5, so you with an order by clause. So you have a lot of options, and it's pretty similar to SQL. Like, one of the things that I try not to get too caught up in when I'm learning let me rephrase that. One of the things that I always like to try to do when I learn another language, and I'll bring up another QL language, and it's GraphQL. I always try to learn it in the context of my knowledge of learning SQL, because I think that's, especially if you're very experienced with SQL, it's the easiest way to learn something like this. You can translate existing database business logic into GraphQL logic very quickly. And you might ask, what's the point of doing this, right? Like, why do I even want to think about doing this when I could just write a stored procedure that does all that? Well, from the perspective of an architect who's building a custom application right now, that involves databases being queried by APIs, I will tell you, a lot of the ORM frameworks your developers work with don't really work well with stored procedures or functions, especially across multiple databases. They tend to work better with discrete SQL statements. So if you're mapping, a GraphQL query directly to a SQL statement as opposed to trying to map it to a function or stored procedure. And I know functions are kind of terrible in SQL Server. I keep saying function because my current project is on Postgres, and in Postgres, SQL stored procedures don't return data, so they're called functions effectively. But GraphQL can really help that, because you can put pretty complex business logic into a GraphQL query that would be either difficult to encode into a direct REST API call, or might be kind of difficult to run into a database, call a database stored procedure through an API endpoint. So that's where we really get kind of the benefit of using some of these advanced solutions. Like, pagination is genuinely a challenge still. Like, it's always been not easy, but when you're dealing with large volumes of data, if you can handle that just in your API response, that's something that can make life way, way easier to do. You can hit the next slide, Andrea. So our arguments are just filters. So you can think of arguments as your where clause. So where you user ID 123, name, email. You could also filter by location or date range. So you could say location New York City, from 2025 01/01 to 2025 1/31 on the title date field. You could also do things like have greater than or equal. So one of the things I frequently do with my Azure VM data is look for Azure VM types that have above a certain number of IOPS. Let's say I want a VM that's got over 40,000 IOPS, because I'm always looking for database workloads. That's something that I can quickly do there. Obviously, I could do that in a SQL query too, but I have a nice API interface to do it. There are a few benefits to that, and we can also use mutations. And mutations are used to perform actions like creating, updating, or deleting data. So when you hear the term mutation, it sounds like something terrible that could happen, or you're corrupting a database. It's simply a way to update, insert, or delete data.
It just means modification.
But just means modification. That's all.
It doesn't mean, it doesn't mean you're going to disfigure your data.
Yeah. Self-corrupt. Do you remember 6.5? It was self-corrupting. But yeah, those mutations, you can use those arguments just like you could a where statement in your update or delete statement. In fact, you should probably always be using a mutation or an argument in your mutations, just like in a delete statement or an update statement should always have a where clause, as we all know as database professionals. You can hit the, go ahead.
Yeah, that's an excellent segue into the mutation we're going to show, which is actually an insert and therefore doesn't have a filter, but go ahead.
It is the safe kind of mutation. We can also combine multiple operators just like we could in T-SQL. So if we want to filter data on multiple conditions to filter data, this can be pretty useful. You can combine and or operators. So GraphQL doesn't have native logical operators like and or in the language itself, but these schema designers will often design them in through input objects. So for example, we can specify query products filter categories and with an and categories electronics price less than $500. So that would return only products that are in the electronics category and cost less than $500. And some examples of with or, so you could say country or country US, country Canada, and that would return all of our users that are either in the US or Canada. And logical filters are usually handled by custom resolvers on the back end that are going to parse and evaluate the condition. So it gives you fine-grained control over data retrieval, and you can build precise queries without multiple round trips or excess logic in the client. And I saw a question come in or a comment come in that GraphQL works fine with stored procedures in SQL Server, and that is absolutely accurate. My comment there about not working great with stored procedures isn't so much GraphQL itself. It's that some ORMs don't work very well.
You meant ORMs in general, yeah. You were selling an upside to GraphQL.
Yeah, like it's we've been struggling on my project and it works, but it's pretty messy. We're using Postgres and we're trying to call a function through a REST API, right? And it's just pretty messy to do. We're using the SQL Alchemy RM, and I was shocked at how difficult it was to call a function with parameters. Whereas if you were passing that same argument in as a GraphQL statement, it would be a little bit easier.
Right. And again, in Fabric, when you go to build the GraphQL API, the wizard is pretty good at just sensing the views and the stored procs that you have in your database, as well as the tables. And it will take care of kind of hooking everything up so that the parameters in your stored procs can map to parameters in your queries or mutations.
Yeah, it's not so much about returning data back from the database. It's more returning data back to the client that we're thinking about here.
Gotcha. Shall I move on or?
Go ahead.
Okay, cool. So like I said, you were talking about how we should always have filters, and that is absolutely the case for update and delete operations. But as luck would have it, our example here of a mutation is one for an insert where a filter wouldn't apply. So forgive that unfortunate coincidence. But note that the syntax is really almost the same thing. Obviously, we're going to start with the word mutation rather than the word query. I mean, I think that's obvious. And then these names are really by convention. That this isn't syntax per se, but oftentimes, and especially with what gets generated by the GraphQL API tooling in Fabric, you're going to see that these mutations are named with a verb and then a noun. So the verb will represent the type of mutation and the noun will represent the data type, right? So in this case, we're adding a country and then we're specifying all of its fields and values for each of those. And again, we have the equivalent SQL up top here where we're saying insert into country, and we are specifying all the column names and specifying all the values. Arguably, this syntax is easier to deal with. I kind of like having the value right next to the name of the the field rather than having to kind of imagine the arrows pointing from each member of the field list to each member of the value list. And notice also, right, the table is called country. Before we had a query called countries, plural, because we could get back multiple. In this case, we're adding one country, so our naming is consistent with that, so it's add country. Again, you can absolutely have filter conditions if you're doing updates or you're doing deletes. You would most likely want those, or else you're going to delete every row or update every row. Well, that's the generality of it. So in the world of Fabric, you're going to write the JSON that you see here, but the underlying implementation for add country is not something you have to write. That's something that will get generated for you. Another thing that gets generated for you is you're writing the JSON for the mutation or the query, but you're not going to have to write your Python code or your JavaScript code unless you want to call it from the application. There's a tool built in to generate that code for you too, which I think Joey will be showing. Also, if I could just be retroactive here, that question that was apparently in the chat, Joey, about, really what is all this for? A major feature of this is that the endpoint that you create when you build the API is externally accessible. So instead of having to go into Fabric to do stuff with Fabric, right, you have a reachable endpoint, provided you can do the authentication to get to it. You have an externally accessible endpoint for working with your data.
Correct, and you could publish that, like you could publish that to any kind of an app you wanted. So
right.
you could make it internal. When we say internal or external, like you could put it on the internet or not, or on the intranet if you were so inclined.
Right. So that's another kind of layer of abstraction, if you will, right? It's a way to provide data, read or write access to the data without having to actually share the SQL Server endpoint for your Azure SQL database if you didn't want to do that. And these slides are a little funny. We kind of say what we're going to say, and then we say it, and then we talk about what we just said. That's sort of what this slide is about. But the point is, we spent more time on queries than mutations, but obviously mutations are important. If you consider the fact that out of the 4 basic operations that you might do with one of these APIs, 3 of them are going to be covered by mutations, and it's only retrieval that's going to be covered by queries. And the mutations are always going to consist of your input type and your payload. And you will see actually more on the query side how to pick those apart in terms of calling the API and getting back the JSON result document. And that's actually what Joey's going to talk about now.
Yeah, so the way GraphQL sends data back, and it handles responses a bit differently from a traditional REST API, and it's important to kind of understand how data and errors are returned. So, like just about everything else with GraphQL, responses are always returned in a JSON format and contain 2 fields. And one of them is going to be data, which is going to be the result of your query or mutation, and errors, which are going to represent any error that occurs. The goal with this structure is to allow for clear and consistent error reporting while providing a flexible way to handle data retrieval, partial responses, errors, and even real-time updates through subscriptions. That subscription model, like Andrew talked about, is kind of that change data capture feed. And we're not really going to do any of that with Fabric, but it's something that you have available. But by handling responses in this consistent manner, it also can provide increased performance through more efficient caching if you're dealing with a caching layer. And this is a big advantage of GraphQL for those API interactions. You can hit the next slide. So like we mentioned, when you modify data, just like if you'd modified it using a SQL statement, using a mutation, the server is going to respond with a JSON object that's going to include the updated or newly created data, which allows for those immediate client-side updates. So once you see that you've modified the data, you can refresh it in the client side. As I mentioned, the response is going to contain any information, any status information or error messages under the errors key. And remember, unlike a REST API, you're only going to get the fields back that you request, which is going to make the response more efficient and predictable. You can also include returning fields in your mutation to request and control additional data that comes back. And if you're using, because it's JSON, it makes it easy to deal with front-end frameworks like React, Vue, or Angular. Well, the demo we're going to do today is a single-page React app that I built for this. And there are other tools like Apollo Client and Relay that can automatically handle those responses and update caches like Redis and display messages to users in kind of a more efficient format.
Cool. So this is my little cameo here, I think. This is the entire code necessary. In this case, it's Node.js JavaScript code to run a query. So you'll notice the JavaScript query itself is right here, kind of in the middle of the top half, if I can use fractions that way. And what we're doing is stringifying it and setting the body of the HTTP request to that, right? We're going to say it's a post, and we're going to set up headers, first of all, to specify that the content type is JSON, but also to push in the right authorization token. So that's the first half. You're going to push it in, you're going to get back your response. And then the response has a data field, and the data field has both an errors subfield to it and a data subfield to it. So that's really all you have to do to parse out the messages, because when we're saying errors here, that really means what I was calling messages before. They might not be errors. They might just be status messages, right? And in this case, what we're doing is sort of ugly. We're just pushing everything to the console. But of course, we could do something more elegant than that and actually put it in a web user interface, which is what Joey's gonna show. Before he shows it, though, let me kind of tell you the one more step required to make that big stored proc that we looked at before callable by GraphQL. And I've got a little bit of an explanation here because it does get a little Rube Goldberg. But so what you saw, that T-SQL you saw before, was the find sessions stored procedure. Within that, we call something called get_embedding, and that was actually developed in Module 3. I didn't show you the implementation of that, but if you looked in the code for it, you would see that we're calling a system stored proc there called SP-invoke external REST endpoint. And that's a pretty clumsy name, but it's a pretty cool procedure because it lets us call out to external REST APIs. Specifically, we're calling out to the Azure OpenAI API and to a deployment that uses the text embedding ADA 002 model to generate the embedding. So that's a lot of stuff. And you saw the implementation for it. But the problem is that because that implementation's so crazy and it's got all the CTEs and so forth, the actual schema of what's returned by that result set is a little indeterminate. So what we do is we build a wrapper around that, which is the thinnest of wrappers, as you'll see in a moment. All it does, we're going to call it find sessions wrapper, and all it's going to do is take an input parameter, and then it's going to call find sessions and pass it the same input parameter. But we're going to use a with results sets so that we can make the schema explicit and thus callable by GraphQL. So I'm going to show you that, and I'm also going to hand wave a little bit and say that Joey's demo is not actually going to call this thing, but it could.
Yeah.
We just wanted to go to our own database and our own table so that I mean, I say we, Joey did all the work here so that we could do a genuine demo rather than a recording. But in order to kind of keep you up to date with the plot that existed in the first 3 episodes and will continue, we want to show you this. So I'm going to go ahead and run this guy. And again, this is find sessions wrapper. Notice all it's doing is taking at text as an input and calling find sessions and passing it right through, but it's got the with result sets at the end. We'll run the script, and what you might have seen if you had a really sharp eye was that the very last column in that with result sets, rather than being called cosine similarity, is called distance. So we just called find sessions, which is what we had before, and the last column is called cosine similarity. We're going to call find sessions wrapper with the same input parameter of Emily, and we'll get exactly the same data back, but notice that the last column will be called distance rather than cosine similarity. That just gives us a visual cue when we see the result set of which one that we're calling. However, you can see it's all the same stuff. If we run this entire script, we get 2 result sets back. Result set 1 was just displayed, and here's result set 2. And the whole point of this is that find sessions wrapper can indeed be called by GraphQL API. With that said, I'm going to give control of the screen over to Joey and let him show you his magic.
Yeah, here we go. So we have an Azure SQL database here, a Fabric Azure SQL database on Fabric. Microsoft Legal, don't shoot me. I just want to walk you through the process of how you create the API, then we'll show the app. So here, I'm going to go ahead and create a name, demo2. And here you can add data objects to it. In this case, it would be tables. Presumably, we have some views. Unfortunately, you can't expand this window, so you kind of have to guess at which objects you're looking at, and they're not sorted by object type. So I can see we have a couple of views in there. I don't remember if
I
AdventureWorks.
think that splitter bar is draggable, isn't it?
It is not.
Oh, that's harsh. Okay.
I can see it like there, and it's not.
Yeah.
I tried this for a while the other day. Anyway, we've got one built, and we'll navigate into there. We'll kill these 2. And so here I have fact internet sales, and it's a pretty wide table. I'm not quite sure where this data came from because it wasn't there before, but I think it's our model and our type. There's a couple of things I want you to note here. There's a generate code button, and this can generate code in Python or Node.js. And this is a little bit weird because this is like about 1/10 of the code you need to do this. What this does is gives you the endpoint you can use for Microsoft Entra Auth, but it doesn't give you the full code. There's a docs page you can go to if you search Fabric Data API Builder, and it will walk you through how to build an app. Just know that this generate code thing does not do everything for you, but you will need to copy this endpoint. So we've defined this API, and it's only using this one particular table. And I'll show you kind of the Node.js code, and then we'll show the app. So first, there are 2 files that are really important in this app. Let me make this a little bit bigger here. And the first is this auth config. And if you've ever developed an application that uses Entra Auth, you'll know this is pretty familiar. This is the client ID, which is the GUID that gets assigned to the app registration that I have. The authority is logon.microsoft.com, followed by my tenant ID in Azure. Feel free to steal that. It's not sensitive. And then I have a redirect URI. I also have this GraphQL endpoint, and we can see that's graphql.fabric.microsoft.com. This is effectively like if we had stood up Data API Builder with a GraphQL endpoint and just kind of ran with it. The other part that kind of matters in where we have our actual code is in app.js. And here's my query that you can see, and it's a pretty basic query. Wait, did my everybody can Andrew, you can see my screen, right?
Yes, I can see it.
Okay, cool.
Yes, sorry, I was muted.
No
I
problem.
said yes, but you didn't hear me.
Yeah, so you can see this query here, and you'll note it's separated by backticks. That's just a JS function. We're calling fact internet sales. We're filtering on total product cost greater than 1,000, and we're returning product key, total product cost, and sales ordered number. I'm not a very inspired developer, so I just kind of put something together. So if I flip back here into this other browser tab, you can see this is just a tutorial app that we've built. And if I call the API, this is going to take a second because if anybody was here before, we were discussing how Fabric Database is serverless. And you can see I don't have an order by on this or anything. It just returns all of the records that have a total product cost greater than 1,000 in product keys. I didn't really have to do much in terms of formatting this. I just had to specify what columns were being returned, and the application was able to handle it. And this is fully integrated with Intra. So I'm authenticated here as Joey at joey@joeydantoni.com. Which is who also owns my my Fabric tenant. So really quick and easy way to put together a light front end, and obviously you could have a more inspired front end and probably a more inspired query. I just wanted to demo that this is something I put together in an hour and a half on Friday. And with docs, if you're a better reader of docs than I, you could probably get it together in a little bit less time than that. It wasn't, from a JavaScript perspective, it wasn't very complicated, but it was a little bit complicated on getting a couple of things to work, but nothing too bad.
If Joey can do it, you can do it.
Yeah, for sure. I'm not a good developer.
All right, there are some resources that go along with this. Again, these were companions to the original presentation of this material, but the resources are exactly relevant still. So the URL's right there, aka.ms/SQL on Fabric/more. And a reminder here, if I can actually get focus over to PowerPoint, that this has been episode 4 in a series of 6. There are 2 more, and those are going to be presented on May 14th and May 28th for this specific audience. So we absolutely encourage you to tune into those, even though we think ours is the most awesome content. We've only got about 2 minutes left.
Somebody asked for an example.
Sharing.
Somebody asked for an example of GraphQL data sets. I would say if you want to learn GraphQL, get Data API Builder from Microsoft. It's free. Point it at your SQL server and start querying AdventureWorks. That's probably the easy, especially for somebody who's a SQL professional. It's probably the easiest way to get started. You could use public data sets, but you're gonna deal with way more hassles with APIs and stuff. You can just run Data API Builder local on your machine and point it at your local database and fire away, and there's no security or anything like that to worry about.
I also wanted to point out, if it wasn't obvious already, that when you build your APIs in Fabric, you can build those not just around SQL database, although certainly you can, and we did, but you can also build them around your warehouses and your SQL analytics endpoints, whether those be encapsulating lakehouses or SQL databases. You'll notice data marts show up here as well, but data marts have been in like permanent preview for literally multiple years. So we're not going to encourage you to use either Power BI
don't use data marts.
Don't use data marts. But if you did use a data mart and you wanted to build an a GraphQL API on it, you actually could. That's all I wanted to say. I'm going to stop sharing. Do we have other questions? Okay.
I think that's about it. I think we're good. Thanks, everyone. It was wonderful.
And it's 4 p.m. on the dot, Eastern time. So
nice timing.
We'll call it a day. Thanks. Nice to see you again, Joey.
Bye. See you, Andrew.
Thank you, guys.
Thank you. Okay, thank you, everyone. I will upload this in the YouTube channel by the end of the week. And if you have any question or comments, like send it to the email address that I shared with you. I'll make sure that I pass those to the speakers and get you an answer.